Now we are going to discuss about deadlock. Now what do we mean by deadlock? By simple definition we can say a deadlock is a situation where processes are stuck waiting forever and no progress happens. That means all the processes are stuck and there is no progress here. Like they are stuck forever. Okay. That means if you consider a situation here, one car, you can see, like let's consider this car. One car blocks each other at a junction so that no one can move. So this is the same which is happening here. See, now this car, if it has to go in this direction, this has to go there. But if this has to go there, this car has to go in this direction. But if this car has to go in this direction, then this car has to go. Right, so that means all of these cars are basically stuck at this junction. Right, they're basically stuck at this junction, all of the cars. So this is the situation what happens in our operating system also with the processes. Okay, that is all the process would get, the process are stuck forever and there is no progress here. A situation where programs continue to run indefinitely without making any progress. Each program is waiting for an event that occur that another process can cause. That means, let's say we have process P1 and process P2. P1 is holding one resources, let's say R1, and P2 is holding another resource, let's say R2. So P1 to get executed, let's say it is waiting for the resource of P2. But if P2 also wants to execute, it is waiting for the result of P1. Understood? If P1 want to execute, along with this, it requires this R2 resources. But P2 is holding R2. But if P2 want to release this R2, it should finish execution. But for finishing execution, the R1 that the P2 requires is holded by P1. Understood? This is a situation of deadlock. So in deadlock is a situation where processes are stuck forever without any progress. Each process holds one resources and it requires the resource of another process which holds which holds a resource, and that requires the resource of the other process. Like, so this is like waiting for each other. That is, here what happens is that P1 is waiting for P2, P2 is waiting for P1 is waiting for P2, P2 is waiting for P1. You can see a circular wait is happening here, right? So what happens here is circular wait is basically happening here. As you can see, a circular wait is basically happening here. So how deadlock can happen? Each process, this is how you can see. Okay, each process requests resources, use the resource, release the resource. That is what, so what happens is that P1, if P1 to execute, it needs, let's say it needs resource R1. So what happens is that it will request this resource R1, it will use this R1 now together, and finally it will release this R1. Okay, that is how this happens. But here what happens is that, let's say process hold resource A and it is waiting for resource B, and another process is holding resource B and it is waiting for A. So a cycle is formed, that is deadlock. So if there is no deadlock, normal condition is what I said. P1, they would request for a resource, it will get that resource A, and after using that resource, it would release that resource A, it would release, now any other process can use this A. But in deadlock, what happens is that the process P1, let's say, is holding, process P1 is holding resource A, and P2 is waiting for this resource A. But P2 is holding what? Resource B. So if P1 want to release A, it requires B also to completely execute that. Understood? So the cycle is formed here. So that means deadlock. If cycle formed, it's what? Deadlock. Understood? So here, as you can see, process 1 is holding resource 1 and waiting for resource 2, which is acquired by process 2, and process 2 is waiting for resource 1. Okay, now there is another important thing that you have to understand, that is the necessary condition for deadlock. Now if you are saying that a deadlock is occurred there, then there are some necessary conditions that should be satisfied for a deadlock. What are the necessary conditions? The first condition is mutual exclusion. Mutual exclusion means only one process at a time can use a resource. That is, the condition requires that at least one resource be held in a non-shareable mode, which means that only one process can use the resource at any given time. Here in the situation, both resource 1 and resource are non-shareable, and only one process can have exclusive access to each resources at any given time. That means here if we see resource 1, deadlock occurs in the case where there is mutual exclusion. That means these two resources can be only used by one process at a time. That is why, since process 1 is holding resource 1, it should not be in a non-shareable, it should be in a non-shareable mode, because if you are able to share resource 1, then process 1 and process 2 both can have the resource 1, right? No. The resources should be in a non-shareable mode. That is, the processes cannot share the resource. Understood? The process cannot share the resource. That is mutual exclusion. Only one process at a time can use a resource. That means if you wanted to use a resource, that resource can be only used by one process. If there are two processes using that resources, then it is not possible. Then that is not the condition of the deadlock. So if a deadlock has to occur, then that resources should be in a non-shareable mode, and that resource can only be used by one process. That is why, since process 1 is holding the resource 1, that is why another process is not able to use them together, because it is in a non-shareable mode. Understood? So the first condition is mutual exclusion. The next condition is hold and wait. That is, one process, at least one resources is waiting to acquire additional resources which is held by the other process. That means one process is holding at least one resources, and that is waiting for another resource that is held by other process. Such situation should come. That is, one process holding and waiting for other process, that is holding. Right? So that hold and wait condition should be there. That is what I said. Process A has resource 1 and is waiting for resource 2, and process B has resource 2 and it is waiting for resource 1. Such condition should come. This condition's name is known as the hold and wait condition. Okay, so first is mutual exclusion. That is, only one process can use one resource at a time. Then hold and wait condition. Next condition is non-preemption. Non-preemption means you cannot forcibly remove a process. That means a resource can be released only voluntarily by the process holding it after the process completed its task. That means if the process, you cannot involuntarily, you cannot force the process to remove this resource. That is, if process 1 has this resource 1, you cannot forcibly remove the resource 1 from process 1 involuntarily. Voluntarily, after the process 1 completes its task, only it is able to remove. Okay, that is what it says. A resource can be released only voluntarily by the process holding it after the process has finished its task. After the process finished its task, after the task has been finished, then only the process is able to release that resource. So preemption means what? Preemption means what? You can forcibly remove that process, but here it's not. It should not happen. I cannot forcibly remove. Understood? That is non-preemption. Then circular wait. Circular wait, I told you, like P1 is waiting for P2 to execute, P2 is waiting for P1 to execute. This is circular wait. So there exists a set of processes, of waiting processes. P0 is waiting for a resource that is held by P1. P1 is waiting for a resource that is held by P2, or any of these resources is waiting for a resource that is held by Pn, and Pn is waiting for the resource that is held by P0. See, P1 is waiting for the resource that is held by, first P0 is, P0 is waiting for the resource that is held by P1. P1 is waiting for a resource, like you can draw the picture, then it will be much more better for us to understand. See, P1 is waiting for a resource, P0 is waiting for a resource that is held by P1, right? Now P1 is waiting for a resource that is held by, let's say, P2. Okay, then like that it is going. Then finally Pn minus 1 comes, that is waiting for a resource that is held by Pn, right? And Pn is waiting for a resource that is held by P0. So a circular wait should be come here, right? A circular wait is coming here. Okay, so these are the 4 necessary conditions for deadlock. Mutual exclusion, only that resource should be one resource, that is one process can only use a resource at a time, that is mutual exclusion. Then hold and wait condition, right? Then non-preemption, that is you cannot involuntarily remove it, only voluntarily, only the process would remove that resource after the task has been completed. Understood? Then finally is the circular wait. Okay, this is about the deadlock. In the next class we will learn about the resource allocation graph. Thank you.